This is section 5.1 on exponential functions, and we're going to learn these questions here. So what do they look like? How can I identify them? How can I graph them with and without a calculator? And how can I use them in real life scenarios? So recall that a linear function has a constant rate of change. So I'm talking linear here. Constant rate of change. That is, the outputs change by the same amount for each unit increases in the input. So an example of a linear equation, which you probably already know. So if I were to do the x and the y, if I were to pick 1, 2, and 3 and plug them in here, you're going to get 4, 7, and 10. And to show that this is linear, this goes up by 3. This goes up by 3, so it's a constant rate of change. An exponential function has outputs that are multiplied by a fixed number for each unit increase in the inputs. So I'm going to show you some exponential functions here. A couple would be here's one, here's another one, here's another one, and here would be another one. So an exponential function has the variable in the exponent. And if I were just going to pick this one, for instance, and figure out my x and my y's, so when x is 1, y is 4. When x is 2, y is 16. When x is 3, y is 64. And if we look at those, these are going to go up by multiples of 4, a multiple of 4. So notice these are being added where these are being multiplied. So graphs of exponential functions, there is the generic y equals b to the x, right there. And b is a positive real number, not equal to 1, because if b was 1, 1 to any power would just be 1, so it wouldn't look exponential. So these would be, b would be greater than 1. And there's a table on page 313 in your book that you might want to look at. So if I was going to actually look at the x-intercepts, the y-intercepts, domain range, horizontal asymptotes, and then the shape, I think I'm going to start with the shape here, and just to give you some idea on that. So if I had y equals b to the x, where b was greater than 1, this is going to look like that kind of a curve. And then if I had another one where I had y equals b to the x, where b was oops, and I should have a negative x here, where b is greater than 1, or if I had y equals b to the x, where b was a fraction, so between 0 and 1. So this other scenario here, it's going to curve down. So this one here has a positive exponent, b is greater than 1, it's going to have a curve going up, where if it was where the exponent is negative or the b is a fraction, then it's going to curve down. It's going to exponentially decay, and this would be a growth, exponential growth. Let's go back up to here. I'm just going to get these written in here. We'll take a look at them on a graph though. So the x-intercept is going to be none. And y is that. And if we look at it up here, if I were going to put in something for x, no matter what I put in for x, a negative number would make it make the y a fraction. A 0 would make the y, so if I had b to the 0, that's just going to be 1. B to a negative x is going to be a fraction. And b to a positive x is going to be a positive number. And notice that there's no x that I could put in that would make the output 0. So y equals 0 is going to be an asymptote. So it's never going to cross that. And then if I look at the y-intercept is when the x is 0, and when the x is 0, y is always going to be 1. Doesn't matter what b is. Any number to the 0 is 1. B to the 0 is always 1. The domain is going to be all real numbers, and the range is going to be all real numbers greater than 0. And then the horizontal asymptote is going to be the x-axis, which is y equals 0. So let's just go ahead and take a look at one of these. So exponential functions are written in this form. It's exponential because x is in the exponent, the variable is in the exponent. So is this exponential or not is the question. So this first one here, I'd have to say no. Because if you look at the exponent, it's not a variable. The second one, I would have to say yes, that is because there's an x in the exponent. And the third one here, I would have to say yes. E is just a number, approximately 2.71, and it keeps going on. It's kind of like pi. It does not end, and it does not repeat. And we get that from a continual, if it's something is compounded, not just annually, not monthly, not daily, not hourly, not by second. If it goes continually, that is where you get into the E. And if you want to look that up, if you're more interested in that, it's pretty cool, but I don't want to spend the time on that right now, but it's on page 375 in your book that shows that. Okay, so let's take a look at these two examples here. So these are two graphs, and they want to know when the B value is bigger. And if you look here, the B value on this one is 10, the B value on this one is 2, it will become steeper. So as the B value gets larger, it becomes steeper. What if B is a fraction or x is negative, then the function decreases steadily? And if you take a look at this one right here, as we said on the very first screen, if that is a fraction, if B is between 0 and 1, it's going to decrease exponentially. Or if the exponent has a negative to it, it's going to decrease exponentially. And if I were to look at that one, this is the same as 3 to the negative 1 times x, which is the same as 3 to the negative 1 to the x, if you remember algebra 2. And 3 to the negative 1 is the same as 1/3 to the x. So if something has a negative power, it's really a fraction. So that's why these are pretty much the same, but we're not going to simplify this each time. We're just going to know if there's a negative exponent, it would be just like the fraction one, decreasing. So let's take a look at this is really our first formal problem here. So notice we didn't use our graphing calculator at all, and we won't be using it for this section here. So is this graph increasing or decreasing? And I noticed that the B is a whole number and the X is positive, so I'm going to say that it is increasing. The next step is, what is the y-intercept? So the y-intercept is a point where the x is 0, and if I were to put a 0 in there, I'd have 7 to the 0, which is 1. So there's my y-intercept. The horizontal asymptote is going to always be y equals 0 unless this were to go up or down. So if it had a plus k here, that's going to change this asymptote. And right now it's just sitting at, so this is going to move the whole graph up or down. And being that the k is 0, the horizontal asymptote is always going to be y equals 0. Horizontal line crossing the y-axis at 0, which is the x axis actually. Find a second point to see how fast the graph is changing. So on this here, and you're going to be doing this on your test, so we're going to put in my x's. I like to stay hover around 0, so I'm going to just do those 3. And you'll see I have a tendency to do those 3 every time almost, unless something else, another number would be easier for me. So if it was to the first power, it would just be 7, 0, which we already have it, right? So we're going to drop that in because we're going to always use that. So that's going to be 1. And then -1, so 7 to the -1 is the same as 1 over 7. A little bit of algebra 2. And then I'm going to go ahead and graph this. So this is going to look just like it would on a test. So I'd have 1, 7, 0, 1, and -1, 1/7. And on your graph, I would like to see a dotted line, because this is going to be the asymptote that it's not going to cross over. And then it's going to go really, really, really close, but it's not going to touch. You got to be really careful that you're showing me that on a test, that I can see that it doesn't cross the x-axis. So you actually get a point for that asymptote, that you are showing me that you know where it is. That's it. So we did all that by hand. There'd be a point for each one of these. There'd be some points here and then points for your graph. If we were to look at transformations again, so I just want to show you these with exponential functions. So this first one here is going to go up 2, because the original one would be, the parent function is y equals 4 to the x. Looks a little different because there's a 4 in there, but that is the parent function. And I just want to point out on this one, the new asymptote. Oops, asymptote. Oh, I did do that right. Is y equals 2, because this one went up 2. So just be really careful that you see that. Just want to separate these out for you. And then this next one here, the original one is going to be, the parent function is going to be y equals 4 to the x. So this one had a reflection across the x-axis. That's the negative there. The next one here, again, the parent function is y equals 4 to the x. So this one, what happened is the x, it went to the right 1. Because it is connected, you don't have to have parentheses on that, but it's to the right 1. Number 23, the parent function again is y equals 4 to the x. So we have this 3 out front, so this would be a vertical stretch by a factor of 3. 21, we have this negative sitting out front here. So that's with the x, so that's going to be a reflection across the y-axis because the x is changing. And then the last one here, we have 2 things going on. We have this going on and this going on. There should be a y equal in front of here. So you are going right 2 and down 3. And I want to make a note that the new asymptote is y equals -3. So just so you're very aware of that, we had 2 of them on here where that would change. The transformation shouldn't have been very big deal, just that the new parent function was, on most of them, was 4 to the x. So knowing how that looks with an a out front, plus or minus, you could have a minus here, and then you could have a plus or minus h, plus or minus k. So if you think about all the transformations that could have happened to that parent function. Here's another one. So we're going to see here, is it increasing or decreasing? And because of that negative right there, I would say it's decreasing. And then the y-intercept, again, the x is always 0. So if I were to plug in a 0 for that, that's going to be 6 to the 0 plus 5. 6 to the 0 is 1 plus 5, so this would be 6. So there's my answer for my y-intercept. And then the horizontal asymptote is going to be different it went up 5, so my new horizontal, it's not going to be y equals 0, it's going to be y equal 5 because it shifted up 5. And then I'm asking you for 2 other points, and I would use, again, 1, 0, -1. And we already have the 0, 1, so we want to make sure we graph that one. And when x is 1, this would be 6 to the -1, because x is 1, plus 5, which would be 1 6 plus 5, which is 5 and 1/6. So be careful you're able to do that. 6 to the -1 is 1 over 6 to the first power, right? You just put that up here so we remember. Switching that around. And then the last one, -1, so we'd have 6 to the negative of -1, so be really careful on that. So that's just going to be 6 to the first power plus 5, which is 11. And then if we were to graph that, again, we want to make sure we have that asymptote of y equals 5. And that's worth a point on a graph. And then the second part here is going to be 1 and then 5 and 1/6, which is just going to be above that line. We know this is decreasing, so we know this is coming down. And then we have 0, 6, which is right here. And then we have -1, 7, 8, 9, 10, 11, so it's going to be way up here. And if any of these points seem off, like it's not coming down, then you definitely want to check that. And make sure your line does not go below that asymptote. And that is all the work that you need to show on that one. Next one here is increasing or decreasing. So on this one right here, I would say it's increasing because there's not a negative out in front of the x, and the 4 is a whole number, not a fraction. So I'd say this is increasing. The y-intercept is when x is 0. So if I put in 4 to the 0 minus 2, which is 4 to the -2, which is 1 over 4 squared, which is 1/16. And there's my y-intercept. And then the horizontal asymptote, it does not move up or down, so it's just going to be y equals 0. That's a horizontal line. And then we need to find, and on this one right here, I chose to do 0. I chose 2 because that would make that 0. And then I chose 3 because that would make that 1. Because I know it's not going to cross over that line. And when I do that, if I put in a 0, that's going to be 4 to the -2, which is 1 over 4 squared, which is 1/16, which we already did right there, right? I didn't have to do that again. And then 2 is going to be 4 to the 0, which is 1. And then 3 is going to be 4 to the first power, which is 4. So I have my y-intercept, or my asymptote, which I want to make sure that I have on there. And then I have 0, 1/16, 2, 1, 3, 4. And you could have picked any points you wanted for these x's. You don't have to pick the ones that I picked. They might be different between you and your neighbor. And then there's that graph right there. I knew it was increasing, so that worked fine with that. We're going to do one more of these. So graph that function there. Is it increasing or decreasing? And because this 3 is whole number and the x is not negative, I would say it's increasing. Again, the y-intercept is 0. So if I put in a 0 for x, I'm going to have 3 to the 0 minus 2 minus 4, which is 1 over 3 squared minus 4, and you could put that in your calculator if you want. You're going to get -3.89 roughly. The horizontal asymptote, being that we're subtracting 4, it's going to be y equals -4. And then we're going to find some points here. And we already have the 0, -3.89. We could try a 1. If I put a 1 in here, that's going to be 3 to the